All right, hello friends. I am here to teach you a brand new topic, a very large one called the Big Three. It is very important. It has to do with how objects live their life inside of C++ when you make them. So let's get started. Of course, I'm going to use a big font when I have an excuse to. So yeah, this is traditionally, though, a difficult concept for CSCI 41 students, so maybe pay a little bit of extra attention to this topic. It is a bit of a weird one. It's something that I don't expect you to have seen before. Though I think my CSCI 40 textbook, if you took it with me, it talked about it just ever so slightly. I do want to get into it deeply this semester. So let's start off with a class that will help us see what's going on with this magical thing called the Big Three. All right, so let's make a box class. Not to draw a box, but just like to hold on to something. It's a box like, maybe I should have called it holder again, but that's fine. Let's make a box class that holds on to one value that is an integer. All right, and I'll put this in a simple box.cpp file. And yeah, I just want a class called box that holds on to one int. And that int, I guess I'm calling val. All right, and that will be private, of course. And so the one window I have, or the way that I get to set this value, is with a getter and a setter. So I can have a getVal method that gives it back. I'll implement it outside in a second. And then I also want a setVal method that can't be const because it's going to change the object. And let's have it just take the new thing you want to put into val. And I'll also give it a constructor that takes nothing. All right. So yeah, and like here's how I want to use a box. I just want to like put stuff in it. Box B, cout, B, get val. Oops. Let's say that the default thing that a box does when we construct it is set the val to 0. How about that? All right, so the very first thing we should see printed is 0. And but if I set B's val to something else, then we should see that when we print it out. We should see the 42. And yeah, let's get that working. So very simple class, nothing new so far, but we're going somewhere with this. So this is box's box method. This is box's get val method, box's set val. Boop. And of course, I could set the value to 0 by default in the constructor by saying val equals 0, but I can be much cooler about it. And oops, I forgot a semicolon right there, excuse me. I can be much fancier and cooler of a programmer by doing that in the initializer list. So I can say val 0 like that, and I can have an empty body. That's beautiful. And then get val is just like return whatever val is, and then set val equals whatever we want it to be. Okay, so that's the box class in a nutshell. I hope you can see it. Not too horrible, right? And it's going to print 0 and then 42, as it should. And it's doing well. Let me show you now the Big Three, and we'll talk about them. All right. So the Big Three are 3 special methods that look like this. These are their names for your class. If your class is called class name, you'll replace that. So for us, it's going to be box everywhere. There's a method called a destructor that's going to be tilde, name of your class. It is kind of the opposite of the constructor. We'll talk about that. It happens when things go away. And it's not something that you normally call. It's something that gets called for you when your object goes away. Again, we'll talk about it in detail in just a second. The next one is called the copy constructor. It's a constructor, same name as the class, but the thing it takes is special. It takes another thing of your type. And the goal of a copy constructor is to take somebody else, take another object of that same type and put it into you as you're being built. So this is like saying, I've already got box B1, default constructed maybe, and then this is how you would call the copy constructor. You make a new box B2 and you give it an old box laying around to have it be copied into B2. Does that make sense? It copies somebody else into yourself. And we're calling that somebody else other. And then copy assignment is very similar to the copy constructor. It copies somebody else into you but not, you've already been initialized using a constructor. This is like later on in the program. All right, so it's the operator equals. That's the assignment operator, yeah? That's when you, like you've already got a box B2, and you've already got a box B1, and then you come along and you say like, I'm tired of what B2 is right now. I'd like it to be whatever B1 is. And so you're bringing B1 stuff into B2. That's what the copy assignment operator does. And so it takes the other thing you want to place into you, just like for the copy constructor, and it returns a reference to yourself so that you can chain assignments. But we'll talk about that some more later. So this is the family. This is the big three. It's the destructor, the copy constructor, and the copy assignment operator. And I like to show you the default versions of all of these. Remember that there's such a thing as a default constructor. We talked about that. If I don't make a constructor, one will be made for me, and it will construct all of my member variables using their default constructors. So that's what that. So this is coming back finally when I said those weird words. Now's the time. All right. So similarly, if you don't make a destructor or a copy constructor or a copy assignment operator, you still can do these things. You can still say like box B2 equals B1. You can still use this kind of syntax. One got made for us, and I want to show you what the defaults are, because sometimes we don't like the defaults. Okay. So let's create those things. Let's create the big three for boxes. So let's declare them. So the destructor is tilde, name of your class, so tilde box, takes nothing. Then copy constructor is another constructor, so there's no return type again, and it's called box, same name as the class, but it takes another box. And we'll be good programmers and take it by constant reference. We just want to look at it and use it as a template for as we build this new box. And then copy assignment operator is the operator equals. As you would expect, it's the assignment operator. You give me some other box. Again, I'll take it by constant reference. I will copy that box into me. It's a method call. And what it returns is a reference to the thing, is a reference to yourself, reference to the box that you just set, which is you. And I'll show you why we do that soon. But that's the setup. Okay, so let's implement them. Let me show you what the defaults are for the destructor, the copy constructor, and the copy assignment operator. Beep. Well, these are, first let me give them their full names. This is boxes box destructor, boxes box copy constructor, boxes copy assignment operator. And here is the implementations of all these. Here's the defaults that you get. I will skip one thing that is part of the defaults, but we're gonna work our way towards it. It's called the self-assignment check. I don't want to deal with that right now. But for the most part, these are correct defaults. This is what you get when you don't actually make the versions, like make a custom version of each of these. They're just there for you. All right. I will also print out when they get called. So the destructor for boxes, actually the default is it does nothing. For the defaults, it doesn't do a thing at all, and it's empty. It will just automatically call the destructors of all of your member variables in reverse order that they were initialized. I'll give you a slide on that in a second, but that's done for you without a body. If you have something else you want to do, you'd make your own overloaded destructor, but this one is gonna do nothing. And we're gonna print out though when it's called. Box destructor called for a box object with the value member variable set to whatever our val is right now. Because I want to make a few boxes and we want to know which ones are the destructor is going to be called on. So yeah, default destructor is it's got an empty body. Crazy. I'm sorry, I put the tilde in the wrong spot. It's boxes tilde box. There we go. And copy constructor. What that one does is it copies other into you, and by default, it will just like set your member variables equal to the others versions of those member variables. So our val becomes others val. That's the default copy constructor. So our val becomes others val. So it's a constructor. I can use initializer lists, and the body's empty. But I'll print something just for fun. I'll say the box copy constructor was called for that kind of box. This destructor was called for this kind of box. Just so we can see which ones these are being called on. And then similarly, the assignment operator is meant to bring other stuff into you after you've been constructed. And so by default, it just sets your member variables to all of others' versions of those member variables. So our val equals others val. All right, so that's what it does. And we can, just for fun, we're going to print out stuff when things happen. Box copy assignment. And let's have this be printed when we're copying the other. We'll talk about other stuff because our val is going to be maybe garbage. In this case, it's something that we're about to get rid of. So let's talk about other there. And yeah, what copy assignment does is it copies all of your member variables. So copy, but using the assignment operator. So it's technically, if we call this now copy assignment, this copy assigns all the member variables. Because maybe those things were maybe your member variables were themselves objects and they have their own copy assignment operators implemented. Crazy, because we know we can do that now. So that's what it does. And it also returns a reference to yourself. All right, returns a reference to yourself. Reference to ourselves. So we have to return the current object. All right. How do you get you now is the question. We can almost do it, right? If you say, remember the this keyword, if we say this is of type box star, all right? It's hard, just like this by itself, in like quotes. This, like the syntax this, let's say like has type, or is a box star. If you just say this, it's a box star, right? Which is a pointer to ourselves. So to get our actual selves, we can say star this. Yeah, that's us. And then if I return that, that's just a normal box. It's us as a box form. But if we ask for a reference to be returned, it will automatically convert that to a reference. So that's perfect. All right. So really, the type of thing I'm returning is just box, but because I'm asking for a reference to that thing to be returned, it is happy. All right, that's similar to what's happening in your vector lab. Okay, yeah, so that's the kind of thing you always return that. And the reason you do that is because, have you seen this kind of syntax before? For similar reasons to like the output operator, like you want to be able to have this return y, and like have this turn into x equals y. Does that make sense? Because otherwise, if this was like void, if this inner assignment was void, then it's like, what does x get set to now? So that's why you return a reference to yourself, so you can keep chaining things. All right. So yeah, that's the implementations of all of them. I hope that makes sense. And here, let me use them all. So I've done the default default constructor. Actually, the destructor is going to run automatically. Whenever this box B goes away from memory, the destructor gets called. So that's right there at that closing curly brace of main. So there it is, goes away. But let's make some other boxes. So let's call the copy constructor. If I say box B2, make it out of B, please. That's hitting the copy constructor. See how that's working? Making a new box B2 out of B. And then I can change it, B2, set the value to something different so that I can print it out and it's different. So like B2, I should have B2's val. I should see 43 output, and that should work. Let's see those run. So there's my 43, and destructors, again, there's the 43, and I called the copy constructor on the old one. Destructors for objects get called when those objects go away in memory and it's main's closing curly brace, like when the box local variables are done with. And so it's going to call those destructors for you automatically in reverse order of declaration. All right. The reason it does it in reverse is because sometimes later objects use previous ones, so it wants to kind of clean up in the right order, and that is the order that it chose. So yeah, B2 goes away first and then B. You see that in the output. Okay, that's the destructor being called by C++ whenever an object goes away. And then surprisingly, another way to make a call to the copy constructor is to do this. If you say box B3 equals B2, it doesn't look like the syntax, but technically, because box B3 is being declared and initialized, this is a secret second way to call the copy constructor. this is still the copy constructor, surprisingly. Seems wrong, but that is just how that works. And yeah, still the copy constructor, and set its value to something different, and print it out. So watch, this is not the copy assignment. There's nothing saying copy assignment here. It was copy constructor again, copying the 43 one, which was B2, into B3 as it gets made. Okay, and then as you would expect, B3 goes away before B2, before B. Destructor. And then finally, copy assignment. That's the one that happens when when something's already been made. It's not a constructor call anymore. Something already exists. So like box B4, default constructed, and if we set its value to something different again, just so that we can see different outputs. Let's say, like, all right, I've used B4. Let's say I hate everything inside of it. Now I want to replace it. So B4 become whatever's in B3, and print its value. It's going to be the same. It's not going to be 45 anymore. It's going to be whatever was in B3, which was 44. Whee, so two 44s go away. See that? And that was copy assignment finally. Okay, so that's the big three. I hope that makes sense. You're gonna want to definitely pause the video, make sure this makes sense. Yell at me, ask me lots of questions, but that is the destructor, the copy constructor, and the copy assignment operator. Here's everything on one kind of page. I hope that makes sense. All right, and yeah, as I was saying, the destructors are getting called right before like main is done. Destructors for all boxes get called right before they get reclaimed in memory and their memory goes away. All right, so right there, because main's about to return. It's like, all right, get ready for returning 0, and then also get rid of all the boxes, every local variable. And yeah, that is the big three in a nutshell. And these are the default implementations. If you didn't say anything, like you actually didn't specify any of those, that would be what you get. It's just not going to print anything, of course. We added that special. But these are the default implementations of the destructor, the copy constructor, and the copy assignment. And I feel like I messed something up. Because when I look at the copy constructor, like, did something go away? Dun, dun, dun. Yeah, it looks like, yeah, I forgot to actually set the thing. Excuse me. Our val becomes others val. Could have sworn I did that, but I must have deleted it somehow. Yeah, so this is the default constructor. The copy constructor is meant to set your val, right? Set val into something else. And I think that should be fine. I guess it's because I kept calling set val that I couldn't see the problem. But that's what was really supposed to happen. Excuse me. All right. So yeah, the copy constructor is meant to bring into your member variable the other's member variables. All right, whatever they are, we just have val. So it's copying it in to us. Okay. Yeah, let me double check and make sure I didn't make any other mistakes. Yeah, so the destructor by default is empty. Copy constructor copies other stuff into your stuff, and copy assignment copy assigns other stuff into your stuff, and always returns a reference to yourself. Okay, so sorry if you were screaming at me through the screen. I forgot to do that. It was supposed to be copying stuff rather than just printing. All right. I think that is what I wanted to say. So these are the default implementations, and they actually do exactly what we want, right? There's no issue with them. The default is sometimes fine. Let me set the scene for things to not be fine. So let's update the box class to not store a just normal int value, but let's have that value be a pointer to an int on the heap. All right, so this box can hold just one value, but it's on the heap this time. And a few things need to get updated. All right, a few things need to get updated. So I'll put this in a file called box.cpp. Okay, that's where I'll put it. And so I'll steal all this. And sorry, I want a lowercase box. And so instead of a normal int, what we will hold on to is an int star. It will live on the heap, okay? And so the way we're going to do that is in the constructor, we're going to have to set a few things, right? So in the constructor, we need to make val be a pointer to a brand new box on the heap holding 0, all right? So instead of doing it this way, I guess I could have set this in a weird way, but let me actually use the body this time just to make it easy on us. I want to say val equals new int and like star val equals 0. That will make a new box on the heap and set that value to 0, making this memory work out. Does that make sense? That's what we want in the constructor. Like val needs to point to a brand new int on the heap holding 0. Actually, there's a way to do it in one line. If you don't do that, you can say new int, and then here's the value you want to make the int out of. It's kind of like a copy constructor call, though ints are not objects. Val points to a new int on the heap that holds 0. So that is how to do it in one line. And get val and set val, like I want to get the actual int back, so like return star val, go into the heap, give me that thing back, follow that pointer, right? Star val gets me to there. And the pen looks weird, let me fix it. Like that, dereference, get me there. And then same for set val. If you want to set the value, it's on the heap, so it's star val becomes that new value. Oops, excuse me. Confusing. So yeah, star val becomes new val, because the new val is still just an int. But all of the, what's it called? All of the big 3 implementations do exactly the same thing. They just, the box destructor does nothing. That's the first thing. Destructor does nothing, and let's see. Destructor does nothing. The copy constructor copies others val into our vals, just like they're still member variables, like copy the other stuff, whatever they're called, into our stuff. The type is just different now. So this is the default copy constructor. It still copies others val into our val, just an int pointer this time. And then assignment, copy assignment, just copies again pointers. It copies the address of other.val into our val. So like whatever our member variables are, they become set to whatever the others member variables are. And you still return a reference to yourself. Okay, so that is that's the answer for all of these. And I think, gosh, how do I want to do this? Yeah, I want to show you some stuff. I think this is a good start. Let's talk. Let's talk about all these things. There's going to be some weird things that happen right now with our current implementation. And I guess I can try to show you something. So here is box.cpp. Let's watch it run. Weird things are happening potentially. Printing 42, 43, 44. But it's showing some weird output there. Is that what I want to show you? I think so. I think that should be fine. So notice the destructor being called like this. All right, so something's going on here, and yeah, let's talk about that. So we'll get to all that. Okay, so that's the default. There is going to be an issue though. There's going to be an issue with the defaults, and I think I want to show you like what should change. All right, so let's talk about these things. So let's go into these in detail. A destructor, that's the tilde one. A destructor is something that's called for you that is meant to like clean up things. So one by default gets made for you that just kind of implicitly calls the destructors of all of your member variables that are themselves objects. And it's always in reverse order of declaration, just in case later things use previous things. But the default destructor has an empty body, since the destructors just always get called automatically, even for your own member variables. So this is the place that a destructor gets called is at the end of the scope, end of the lifetime of an object. So like at the closing curly brace that contained that box, if it was on the stack, or if it was on the heap right as you call delete. All right, so there's that. yeah, destructors, they get called on objects right before they go out of scope, or you delete them if they were on the heap. All right. Our default destructor right now, it has a memory leak, surprisingly. Let me, let's just kind of simplify all this. So there is that output that I just showed you is a hint as to what the problem is that we're going to. But right now, if I just like take it back to B, and we're just deleting B, because it's getting reclaimed right before we return 0. You see it get called, but there's actually a memory leak right now because that heap memory is, it's different than B, right? B's stuff, B holds this val, and that goes away when the destructor gets called, right? That goes away, but it's like when the destructor gets called, all the memory associated with the object itself goes away, but anything else it made itself, C++ doesn't automatically know about that. So that heap memory that we created on that int on the heap will not get deleted actually in the destructor right now. Does that make sense? So it has a memory leak, and we can check that. There's a program called valgrind, which is really cool. You can run your program within valgrind. It's called valgrind. And then you say -- leak check equals full, and then you try to run your program like /box. And it says definitely lost 4 bytes of memory. So we lost an int worth of space, which is that int on the heap. Okay, so we really did leak memory, and that's a problem. All right, so the one way for a destructor to get called is like you go out of scope, or somebody could have made a box on the heap. Why not? Equals new box. And then like you use it, and then when somebody says delete B2, right there, that'll also call the destructor before getting rid of that memory, similarly to stack memory going away. Okay, so that is that's the destructor. Let's fix it. So how should we be fixing our destructor? We should be getting rid of this extra memory that we made that is not actually part of our object. It's the thing that val is pointing to. All right, that's separate from val itself. It's a second box, right, in this picture. It's this box right here. Our object is, from C++'s perspective, is just everything within B. But we're making extra stuff, and we got to clean up after ourselves. That's the point of overwriting your destructor. If there's a memory leak, you fix it. So default destructor is empty, but we don't want a default destructor anymore. We need to delete val, right? So not return, but delete the thing at that address. And so then recompile, rerun, nothing changes, but all heap blocks were freed. No leaks are possible. That's me using this thing called valgrind again. That was this command right here. And that's great. So we're cleaning up after ourselves now. Okay, so there's that. And I think that is a good start. Yeah. Okay, oops. Back to the slides. So that's destructors in detail. Copy constructors in detail. They're not too horrible, I hope you see. Again, one gets made for you automatically, and the default version of it just copies each of your member variables from somebody else's in the order that they were declared. All right, so say you had an object called B1 maybe, and it had a couple member variables, X and Y, separate, different from ours right now. And you wanted to like make B2 in B1's image. So you'd again make an X and a Y like you're getting ready. And what the copy constructor is meant to do is it brings into this brand new X the other's X, B1's X. It's kind of doing this. Boop, boop, boop. But it's not pointing, it's just like moving the value in there. That's why I'm doing a dash line. And then the Y, like it's coming from there, it's being copied into there. Yeah. So in your initializer list, it's doing this kind of thing. Like my X becomes other's X. This new object's Y becomes other's Y, where other in this situation would be B1 and the thing you're building is B2. Okay. Yeah, so copy constructors, you call them when you're building a new object out of an old one, but also in function calls, copy constructors are being called implicitly for you, which is nice. When you pass an object by value, so like not by using references or pointers or something, that copies the object. And how do you copy an object? You use the copy constructor. So that's being called for you, and that's been happening for us automatically because we just didn't, we were using the defaults this whole time. That's pretty neat that it just works. So as an example of this, let me make another function, and I'll call it, I want to do something just simple to show this to you. Let's call it val plus 1. So it's going to take a box by value, so not by reference or anything, and it's going to just like return its value plus 1. How about that? All right, so here's my silly example function. It'll be called val plus 1. So it'll take a box, and it will return b's value plus 1, using the getter, of course, because we're not part of the class anymore. And notice what I'm not doing. I'm not saying box reference, or even putting a const there. I'm saying box b, just by itself. And so when there's not a reference, this means b is a copy, right? B is a new parameter. It's going to be a local variable to just this function, and it's going to be a copy of whatever's passed to me. All right, so b is passed as a copy using the copy constructor. Using the copy constructor. Isn't that fun? So there's that, and let me call that. So cout val plus 1 on b. Oops, sorry, I need to recompile. Recompile, rerun, and it runs, and I get 43, which is 42 plus 1, but I also get a weird looking error. And where I'm going is explaining that error. Do you see it? Do you see the problem right now? Because there is a very subtle problem. But when I call val plus 1, I'm passing my b into val plus 1's b. It's a brand new box called b. Does that make sense? It's being copied into there for the duration of this call. Isn't that cool and weird? And then it's using that, and then this b goes away, so it's being destructed. All right? And think about what that means on the heap. Because then we come back to here, of course, and finish main, and then this b gets destructed. Yeah. So that's interesting things are happening. Interesting things are afoot, and that's copy constructors. Finally, copy assignment operators are again a way to bring somebody else's member variables into you, but after you've been constructed using some other means. So again, one gets made for you automatically. It's just going to, by default, set each member variable of the object you're copying stuff into using copy assignment operators to the other stuff, all right, in the order that they're declared. So remember that copy assignment operator, that just means the equality. That's the assignment operator in C++, which we can actually overload. That's crazy that we have that ability, but we can. All right, so that's the equals. And yeah, you have to return a reference to yourself. I kind of mentioned that in passing. I'll draw it out on the slide for why we do that. But again, the idea is for a copy assignment, you've got some object, b1. It's been constructed. Let's say it's got like an x and a y member variable. And then you've got a b2 already just laying around. It's been constructed. It has its own x's and y's because it's of the same type, and they're set to whatever you want them to be right now. But you're tired of whatever b2 stuff is, and you come along and you say on a line by itself, b2 equals b1, semicolon. And what that's going to do is it's going to reset, right? By default, it will reset the contents of the member variables of b2 to be whatever b1s were. So it's going to bring the x value into this x value. It's going to bring this y value into this y value. Does that make sense? That's what's going to happen by default. And you have to return a reference to yourself so that you can chain assignments, but also the implementation of this. If x and y were your member variables, it would look like this. It'd be like x equals, make it others x now. I'm tired of whatever it used to be. Y equals others y. Other.y. Beautiful. And yeah, that's the default implementation. Just brings into your member variables the contents of the others' member variables. All right. And you return a reference to yourself because this cool thing is allowed in C++. Let me show it to you with ints. So have you ever like learned to make 3 blank variables like set to nothing so far, and then set them all at once? Like I want x, y, and z to all be the same value. Like you can do that in one line with this, right? X equals y equals z equals like 42. And the reason this works is because C++ will draw parentheses like this, and it will do the z equals 42 first, and then y gets set to whatever this thing's result is. You see it? And so what happens in an assignment operator is it returns the left-hand side of the assignment, the thing that has been assigned to, which in the case of a copy assignment operator, you're on the left, so return yourself. Yeah, that's the goal. So yeah, you are on the left, you are a box, return yourself. And the way, again, we return ourselves is we return star this, return a reference to ourselves. And yeah, so this is going to turn into z. So that becomes now, as C++ is running this line, it's like the next step is x equals y equals z. Like that's the next assignment. Do you see it? And then this will complete set y to whatever it needs to be, and then return this whole result becomes y. So that's x will get set properly into y. Or sorry, y gets set into x. There. X gets that value. And that is why you return a reference to yourself, because if this was just void, you couldn't chain like this, right? Because then what would y get set to? Who knows? It wouldn't even compile anymore. So that's why you do that. There is one thing in the default copy assignment operator that I did not show to you. It's called the self-assignment check. Here's something weird that you can technically compile and run. You don't usually want to do this, all right? You want to disallow this. You want to like, all right, if you have B1, you can technically call the copy assignment operator like this, right? Say B1 equals B1. That will run your code. But like B1 is already B1. It's having like an identity crisis. So what we should do is make this line do nothing. And that's what C++ does for you. So make this do nothing. And the way you want to know, like, because you want to check, this is called the self-assignment check. You don't want to assign yourself to yourself because that's just a weird philosophical question that we don't want to deal with right now. All right, it might make weird things happen, especially if you have some custom code in your copy assignment operator, right? So we want to make sure that we're not equal to the thing we're trying to copy into us before we do anything. All right, so it's called the self-assignment check. We want to check if the other box is us in memory. How can we check that? I kind of gave you the hint. So we kind of want to do it up here before we do anything at all. We want to do a self-assignment check, and we want to see like, hey, is this other thing actually me? So I know me. The address of me is this. Can I check that to other? You better believe it, because other also has an address, right? How can we check? We use the this keyword. We check our address and the address of the other box. Because if they're the same exact address in memory, they're the same exact object in memory, yes? So that is our self-assignment check, and that's how it's by default implemented. So we'll keep the call being printed, of course, but that's not part of the default anyway. But it would be at the start before you try anything at all. This is the self-assignment check. Don't let us copy ourselves into ourselves. Yeah, it's weird. So we check, hey, is the address of me equal to the address of other? If so, do nothing at all, please. So we still have to return a reference to ourselves, but that's all. So return star this. Don't try to copy anything. Don't try to run any custom code, because we are just having an identity crisis and there's nothing really going on right now. We're trying to copy ourselves into ourselves. We are already ourselves, okay? That is a little weird and philosophical, but I hope you see the point of that, okay? Especially if you had extra code, it would run that weird extra code that might do odd things, okay? So yeah, these are the correct default implementations, or sorry, the correct implementations of the defaults for copy assignment and copy constructor. This is the non-default implementation of our destructor. We noticed we needed something that the destructor by default didn't do for us. We had to consider some memory that we made ourselves. And that's the whole point of overloading it. We noticed we needed something to change. Okay, so with all of that, okay, I have one question for you now to think about. I have a question for you to think about. It's a very interesting and important question. I claim that there's something wrong. We saw a runtime error, and I kind of explained it. I want to copy all of this into a new file and eventually change it to be perfectly correct. So I'll call that, I wanted to call it boxcorrect.cpp. It's still not right. But like with this code, with this implementation of this destructor, this copy constructor, this copy assignment operator, okay? If I run this code, which is very similar to the code I already had before, and I print this stuff out, what will be output? Can you think about it? So the stuff that I'm talking about is looking at box.cpp. So if you're watching the video right now, maybe go to the code from class and scroll through box.cpp. I'm not going to change that anymore for the rest of the lecture. These are the implementations. Like this is the destructor. This is the copy assignment, or sorry, copy constructor. This is the copy assignment operator. Here's the normal constructor. Normal get val, normal set val. All right, they're all happy. So there's those. Here's the destructor, copy constructor, copy assignment operator. Hopefully that was all you needed to see. And so if I run these lines, what is going to be output? Please pause the video and think about it. All right. Highly, highly encourage you to try this. Dun, dun, dun. You ready? Let's see. I want you to work it through in your mind, though. All right. I'm just going to copy and paste, but I've got places to go with this. I've got to use the rest of my time wisely. You should have stopped the video and tried this. So let's get rid of everything other than this, I think. Yeah. So I'm going to correct things in box correct, but it's box.cpp's implementation that I'm using this on right now. Because I just copied that. So here they all are. Let's compile and run. Really, I should be saying after the makefiles lecture, I should be saying that this is really compiling, linking, and running. Huh. So I get 44, 44, 44. And then also I get a weird runtime error. All right. That was the question. I would really like it to be 42, 43, 44, right? Morally, that would make the most sense. This is what it should have been, right? That was what a normal implementation of this would look like. Like, all right, B1 is its own thing. Its value is 42. B1's value when I print it should be 42. I'm never messing with B1 again, right? B2, I'm copying it. I'm making it in B1's image, but I'm messing with B2 after that. So B2 should be set to 43. And then B3, it's default constructed, so its value is 0, but I'm copying B2's 43 into it, but then immediately getting rid of whatever was there and setting it to 44. And now it should be printing 44. So it should be printing 42, 43, 44, but it's not. It's printing 44, 44, 44. Do you see the problem? You see it? It's really subtle. It has to do with our member variable. It's a pointer, isn't it? What happens when we call setVal? It's going to that pointer's address. What happens when we copy stuff? All right, so let's draw it out. So this is what our current defaults are doing. This is what the default copy constructor and copy assignment do for us, okay? When we made B1, it makes a the default constructor, right? For B1 is going to make a brand new int on the heap, and val will point to that. So maybe this was, I don't know, and it will hold 0, of course. So this will, we'll do that. And so say this address was like 100. It's like val is holding 100, yes? And then we're setting the val to 42, so we're going to change this box's value to 42. And then we make B2 in B1's image. And what does the copy constructor do? By default, it's going to set our new value to others val. So it's bringing into B2's val, B1's val, it's copying the 100. It's copying the address. Does that make sense? So B2's val is holding 100 and it's pointing to 42. Do you see that? And then we're setting that val to 43. So it's like following the pointer, setting this box to 43. You see the issue? That's not good. And then box B3, that's default constructed. So for a split second, this val is pointing off to like over here, a new place on the heap, like address 104, set to 0. And then though, we come along and we say B3 equals B2, which is copy assignment this time. These are different objects, so we skip past the self-assignment check. B3 is not B2. And we bring all of B2's member variable values into B3. We set our val to others val. So B3's val becomes B2's val. Whatever's there, the 100 is there. So this becomes 100. We just leaked memory. Oh no. And then also, this is, do you see how nefarious this all is? That's disgusting. So that's happening. And then for a split second though, it was 104, right? It was 104. Now it's become 100 by doing that copy assignment. So now it's 100. We're doing that. And then saying B3.setVal, it's following the pointer, going to address 100 now, setting it to 44. That's gross. So not only did we leak memory, we've also got some issues with the destructor. Like all of these places are pointing to the same place, first of all. That's why we see 44, 44, 44, and that's why it was horrible. Also with the destructor, remember what the destructor is going to try to do. That's why I get this runtime error. The destructor, we've made it correct. It's got to delete the address on the heap. So each of these are going to try to delete address 100. It can only go away once. Do you see that? That's extra bad. So we're doing what's called, we're trying to free this memory 3 times. It fails the second time. It's called a double free. And so that's why you see that error message. So that was crazy. That's a wild ride, right? So that's what the default copy assignment and copy constructors do for you, even though we have a correct destructor, right? The destructor is fine. It's meant to delete its memory, but it wasn't meant to have everybody share this, right? What we really wanted to have happen was, okay, B1, its value, it's default constructed. It's going to make a place on the heap that is holding 0 initially. And then we set the value to 42 like this. And then we make B2 out of B1, but we copy it in a normal way. This is the way we wanted to do it, right? We wanted to do this. Copy and make a new box just for B2 right on the heap. Put 42 there, but put the value there, not the address. Yeah, it's the difference. The value at the address versus the address itself. That's the key here. Then set val to 43. That would set this, right? We would like this to have to be happening. And then same for B3. B3 has a it makes a new box on the heap, holding 0 initially because it's default constructed, and then we immediately set B3 to B2. So what we would like to do is like, let's see, what we would kind of like to do is like, okay, you could be setting like the existing box's memory to like 43 if you wanted to. That would work. But like a more generic way of doing this that will always work out is just kind of like, okay, if you say I want to copy assign somebody else into me, that means I'm tired of myself. That means I'm done with all of my memory. Go and delete it, and then kind of do what the copy constructor did. Then like chop this pointer off, make a brand new box on the heap that points to a copied value from B2. So take B2's 43, put it here. That's kind of the idea. So put the 43 there and then set its val to 44. Okay, I hope you can kind of see what's going on there. And that's the goal. We would like everybody to have their own box and also clean up after ourselves when we're doing copy assignment. Like make sure we're doing everything correct again. We're not leaking any memory there, all right? Because this was also gross because we leaked memory too. And then we also try to destruct and delete the same memory on the heap a million times. Do you see how the destructor would totally work just fine here? Because it would delete each of these things' memory addresses on the heap. They're all separate. There's no issue. There's no double freeing. That is what we want, all right? And the name for what we want is called a deep copy, all right? We wanted to make a deep copy. It has to do with talking about references and pointers on the heap, all right? Or just pointers anywhere. So this is what we were doing is called a shallow copy. Try to see the difference because I've made these pictures for us. All right. So a shallow copy is we've got like an array, let's say, on the heap. We want to copy into a couple places. It's like this exists starting in address 100. A shallow copy is giving address 100 to 2 pointers. Right? They're copying, say like it's copying x already existed first, say. It's copying x into y, but at a very shallow level. They're talking about the same place in memory is all. Yeah? Not real copying has gotten made. It's copied addresses, not actual values. Okay? If a deep copy is what we really need, and that's the difference, right? A deep copy is saying, okay, I want to copy x into y. I will make a brand new thing on the heap, maybe, if it has to be a heap thing. I'll make a brand new array of the same size and copy all of x's stuff into that new thing and give this just to y. Do you see that's also a copy? It's also copying x into y, just like this, but it's copying the value rather than the address. You see it? A deep copy is more thorough. It's deeper. It's copying the values at that address versus just the address itself. Shallow versus deep, because if you mess with x here, you've also messed with y and vice versa. Whereas for this one, they each get their own thing, and there's no issues. Nobody can step on each other's toes. So that's what we wanted. This original default implementation of copy assignment and copy constructor was doing a shallow copy, was copying addresses, whereas we really wanted to do a deep copy and copy values at addresses, make new places on the heap for everybody. All right, that's what we wanted all along. Now we have the words to say it, and we have the pictures to explain the idea. That was the goal. All right, so the default copy constructor and copy assignment operator, they do a shallow copy. They're just copying the contents of the member variables, which are themselves just addresses, right? That's not good enough for us anymore. They just copy the pointers, not what they're pointing to, all right? A deep copy is when you copy every single piece of data. Everybody gets their own version that belongs to just them. Go as deep as you need to. Follow all the pointers and the arrows. That's what we want. All right, let's fix it now. Let's fix it. Let's do it right. Let's do it like this. This is so fun, right? This is so satisfying to see the problem and know exactly what we need to do to fix it. Let's fix it. So it was, destructure's fine, right? Destructure's fine. It's meant to have its own memory. We just didn't do that before, all right? We did the destructor correctly. Copy constructor needs something to change, right? Copy constructor is instead of this copying just the values, what we want to do is we want to say that our value is a copy, like on this line, right? B2 is made from B1's image. B2, take B1's stuff on the heap, make a new box for just us on the heap, and copy that value into it, all right? So that's this. This is saying our val, make it a new int on the heap, brand new int on the heap that holds the same value as others val, that is the int, right? I could also have said other.getVal here, but like go to the others val on the heap, like get the 42 out, put it in our own 42 just for us, our private version, right? A second box on the heap. Do you see the difference there? So new int on the heap for this value. That's what we wanted. It's just ourselves, just for ourselves. It's a new int, right? It's brand new box. But the value that it holds is a copy of an old value. Yeah, so that's happening. Self-assignment is still correct for copy assignment. This is the problem, right? We want to copy assign the member variables in a different way, right? What we wanted to do, a good generic way of doing it, because I could have changed the existing box on the heap. What I want to do is delete my old stuff and then kind of do the copy constructor's job again, bringing in the old stuff to a new place on the heap, the other stuff to a new place on the heap. So I'll do it that way. I'll say delete my val, because I'm done playing with that one. I'd like to make my val equal to a new int, right? Holding again whatever other held. So just like I did in the copy constructor. That's why I recommend you start learning it this way. You could have made this slightly more efficient, but this just becomes like delete what we had and then do exactly what the copy constructor did. That makes it easy for starting out. Okay. So yeah, another new int on the heap for this value. I guess I could have copied that entire line. Cool. And you still return a reference to yourself. All right. Everybody else, everything else is fine. That's all. It was just those defaults were bad defaults. And now I won't get any errors, and I won't leak any memory either. Boop. Do you see how these are all, that was the original problem, I hinted at it. All these addresses of these values when we're printing out the destructor, they're actually different now. That's perfect, all right? And I get my 42, 43, 44, and if I val grind it, all heap blocks were free, no leaks are possible, okay? So that's great. That's great. That's what we wanted. That is the secret, all right? So we were messing with memory on the heap. We noticed there was a problem in the destructor, so we fixed it. And then also there were problems with the other defaults for the copy constructor and the copy assignment operator. And that's the story, right? That's what happened. So the default implementations of the big three sometimes are not what we want. And the main way this is going to happen in this class is when the heap is involved, because we're messing with our own memory, and then we gotta do stuff, right? Copying looks differently when we're making heap memory, right? It's something that's not just local to our object. So especially when the heap is at play. Okay, and so you have to override them, again, if you don't like the defaults. And the defaults don't work a lot of the time when you're making your own memory, right? When you're messing with stuff on the heap, in addition to other times too. This is not the only time, but yeah, that's kind of the goal, is if you notice that something's wrong with one of your big three, that means almost certainly that something's wrong with the other two, and you got to fix them all, okay? That's where we're going. So yeah, that's the start. And yeah, now that we have the correct implementations, here is the implementation, the correct implementation of the copy assignment operator from the relevant part that I'm asking you a question about onwards. Yeah. There, I'll include that part of the comment. So here's the code. Could you explain now what would happen if we didn't use the self-assignment check? Because this is actually where one of the reasons why the self-assignment check is bad, or sorry, it's necessary. It breaks things. It's bad if you forget it. All right. Because what if I did B3 equals B3 where this was B3? All right. If this was B3, it had a val pointing onto the heap holding 42. If I didn't have the self-assignment check and I just let this fall through, if I got rid of this part, if I got rid of this code, what would happen? Can you imagine? Can you see it? Talk about the whole object, talk about, because other things are going to run, right? Talk about the entire lifetime of the object. Can you explain in words what would happen? Do you see it? So if we let that fall through, we would, first of all, we'd delete our value. Now we've lost our 42, our one and only 42, right? This is why you don't want to have an identity crisis like this. You don't want to let it happen. So you delete your value, and then you'd be like, I would like to make a new val on the heap. So you're going to make a new int, and it's going to hold other.val, but other.val was me. I'm trying to access heap memory that has been deleted. So you're most likely going to get garbage. Sometimes you might get 42, like the heap hasn't cleaned up fully just yet, but you cannot bank on that. And then val's going to point to potentially garbage. It's called undefined behavior. You've just chopped that pointer off. That's why the self-assignment check exists. Yeah, that's why it's necessary. That's important. So also that, and yeah, we've leaked memory, and we're not going to get rid of, actually the destructor is fine, isn't it? Because we are actually deleting this memory. We're not actually leaking any memory. We've just forgotten our actual value, right? We've forgotten the value we really cared about. We just deleted the one spot where we had it, okay? So that's why we want to do the self-assignment check. This won't usually, this is very apparent that you'd never want to do this, but maybe like sometimes like you have two pointers or something, and like star B3 equals star B4, but really they were pointing to the same thing. So there's a way to get at this weird looking, a line that kind of looks like this inadvertently. So it's important to remember the self-assignment check, okay? So yeah, well, what would have happened is, yeah, the copy assignment operator usually checks for self-assignment. If so, does nothing. Otherwise, it deletes all of your heap memory and tries to recreate a deep copy, right? Because that's the correct implementation of your stuff, trying to go to the other stuff. And if other was the thing you just deleted, who knows if that's 42 anymore, all right? You access deleted heap memory, and that's called undefined behavior in C++, where who knows what happens at that point, all right? So don't forget to check, that's important. And yeah, I hope you see like this is a little bit complicated, but it's not horrible, right? There's just a lot of things involved. So let's talk about some of the things for object-oriented programming that we know about now. So this is a default constructor call, right? Default constructor, you just say the thing, no parentheses, no calls, no giving arguments. It's just default constructor, no arguments, no parameters. There's another way to call the default constructor. If you were to make your object on the heap, if you make a pointer to a box on the heap, box star b, it's meant to be a star. Let me fix that. Box star b equals new box. This is also calling the default constructor. It's just making that box on the heap this time. And then this is the parameterized constructor. It makes a box on the stack, calls its one of its constructors that took an int. Likewise, if you were making your box on the heap, this is how you would say it and hit the parameterized constructor. You'd say new box, and you'd put the argument right there. That would call the parameterized constructor and make that box on the heap this time, right? Rather than the stack. Copy constructor, just like that. It's bringing B into B2 as it's getting made. If you wanted to do that for heap stuff, it'd be like box star B2 equals, give me a new box on the heap. And a copy constructor is just a constructor, but the thing that you give it is an actual box. So assuming we're using pointers, say that that was like star B. It's like this one, copy it into me. Okay, so there's that one. Copy assignment operator. Again, its job is like you've already been constructed in some other way, but you're tired of yourself now. You're having a midlife crisis and you're bringing somebody else into you, all right, to try to rejuvenate yourself. So the other way to do that on the heap would be like, you've got all these things as pointers to heap memory, like star B2 equals star B. If I were using like these, for example, copy assignment brings the other stuff into you using a deep copy if you did it right. Yeah, don't do the defaults sometimes. Sometimes it's not good enough. So that's that. And then the destructor is just implicitly called for you when it's a stack thing. If the box was made on the stack, it's closing curly brace, or like a line that returns is going to cause that local memory to go away. So it's going away right there, or like right before a return. So there's that. Boop. So right there. Otherwise, if that box was on the heap, you have to say when you want it gone. So delete your box B3, for example. That's where you'd say that, and then just the line delete, in addition to deleting the memory belonging to the object itself, also deletes, like it calls the destructor and does any extra things that you have in the body of the destructor, like delete other heap memory that you've made for yourself. Okay, so that is a recap of all these things. We knew about the constructors, but I guess we didn't know the full story because we gained a new one that's a little weird looking, and we learned about the big three, which is these guys: copy constructor, copy assignment operator, and destructor. And these are the right way to do it for a class called box that's holding stuff on the heap, because this bottom picture is much more sane. I hope you agree. All right, so study the difference. This is the stuff that's happening in like normal box.cpp. This is the box correct implementation. All right, so that's the file structure we've worked on so far. The defaults work when you're not using the heap. That was box simple.cpp. The defaults are horrible when you're using the heap. That was box.cpp. And then the correct version of everything, the overloaded versions of everything, is in box correct. Okay. And I think that's where I want to stop for the day. So yeah, I hope you see why this is a bit more of a difficult concept. There's a lot of moving parts, but it's not too horrible if you keep studying. So yell at me, ask me lots of questions, and I will see you in the next video.